In this lesson, we're going to discuss one-to-one and inverse functions. So first, a one-to-one function pretty much means that each input has its own output. So it doesn't share the same output as any of the other inputs. So in part A, or for A and B here, determine whether the following functions are one-to-one. The age compared to HDL cholesterol is not one-to-one. And that would be because 55 and 61 have the same output of 38. So since they both have the same output of 38, then it is not one-to-one. So it is a function because there's no repeat in the x values, but think of it, there's a repeat in the y values, so it's not one-to-one. Part B, that set of ordered pairs, there's no repeat in the y values, so each input has its own output, so it is one-to-one. Another way to test if a function is one-to-one is the horizontal line test. So you have your vertical line test that tests if it's a function. Your horizontal line test tests to see if it is one-to-one. So you could look at the graph. So f of x equals x squared we know is a parabola. If I draw a horizontal line anywhere through there, it crosses more than once, so this is not one-to-one. For the graph g of x equals x cubed, it's something along these lines. If you draw a horizontal line anywhere, it only is ever crossing once, so it is one-to-one. And that makes sense with the definition for the parabola. Like if you plugged in 2 squared is 4. If you plugged in negative 2 squared is 4. So there are repeats in the outputs. All right, finding an inverse here. The notation that you're going to see used is the symbol F inverse. All right, so if the point AB is on the original function, then the point BA is on the graph of the inverse of that function. So the domain of the original function becomes the range of the inverse, and the range of the original function becomes the domain of the inverse, and that is always true. And the inverse is symmetric about the line y equals x. So we're going to use that fact here to draw the graph of an inverse. So we're given y equals f of x, its graph, and we are going to graph its inverse. So take those ordered pairs, 2, 1, negative 1, 0, and negative 2, negative 1. The graph of its inverse will have 1, 2 on it, 0, negative 1, and negative 1, negative 2. So plot those points. And you have this. All right, and if we sketch in the line y equals x, that would be this line here. So you can see that the inverse and the original function are symmetrical about that line y equals x. So next, to verify if functions are inverses of each other, we need to show that f of f inverse of x, so that composite, is equal to f inverse of f of x, which is equal to x. So we're going to find the composite of those two, and if they are both equal to x, then they are inverses of each other. All right, so for g of x here, let's find g of g inverse of x. So we're taking and finding g of the cube root of x. Well, that would be the cube root of x cubed, which is equal to x. So g of g inverse of x is equal to x. Doing the same thing for the other way around. So now we're finding g inverse of g of x. Really, we're finding g inverse of x cubed, which is the cube root of x cubed, which equals x. So because g of g inverse of x equals g inverse of g of x, and they equal x, then they are inverses of each other. Same thing here in this next example. F of f inverse of x is really, we're finding f of 1/2 x minus 3. So plugging that in, we have 2 times 1/2 times the quantity x minus 3 plus 3. The 2 times 1/2, 2 times a half is just 1. So we have x minus 3 plus 3, which is just x. F inverse of f of x is f inverse of 2x plus 3. So substitute that in. We have 1/2 times 2x plus 3 minus 3. 3 minus 3 is 0. Half of 2x is just x. So those two are in fact inverses of each other. And last here we have how to find an inverse. So rewrite the function as y equals. So instead of writing f of x or g of x, replace that with y equals. You're going to interchange the x and the y variables, and then you're going to solve for y. And that's how you end up with the inverse function. And you can always check the result by what we just did to see if it is correct. So here we're going to find the inverse of f of x equals 2x plus 3. So rewrite it as y equals 2x plus 3. We're going to interchange the x and the y, so now we have x equals 2y plus 3. And now we solve for y. So we have x minus 3 equals 2y. Divide everything by 2. That's x minus 3 over 2 equals y. So f inverse of x equals x minus 3 all divided by 2, or that can be written as 1/2 times the quantity x minus 3. Either way is perfectly fine. And if we looked at those graphs, you would see that any ordered pair on there would, on the original, the inverse would have them just flip-flopped, the x and the y. All right, and let's find the inverse for the function f of x equals 2x plus 1 over x minus 1, where x cannot equal 1. So because it's 1 to 1, it has an inverse. So rewrite it y equals 2x plus 1 all over x minus 1. Replace or interchange the x and the y, so now we have x equals 2y plus 1 over y minus 1. We need to solve for y, so let's multiply both sides by y minus 1. So on the left we have x times the quantity y minus 1 equals 2y plus 1. We can go ahead and distribute on the left. So that's xy minus x equals 2y plus 1. We're trying to solve for y, so we need to get the y's together here. So let's subtract 2y from both sides. So xy minus x minus 2y equals 1. We need the y's together, so let's get the y's together on the left. I need to add x to both sides. So we now have xy minus 2y equals x plus 1. And I gotta get just a single y. So right now I have y in both terms there. So that means I can factor out a y. And we're left with x minus 2 equals x plus 1. get y by itself, divide everything by x minus 2. So y equals x plus 1 over x minus 2. So our final inverse function, f inverse of x, is x plus 1 over x minus 2, where x cannot equal 2.